Hello everyone, welcome to Professional Cipher. So today's topic in our convolutional series. This is the third episode on convolutional neural networks. So today's topic is channels in CNN. We had stopped giving a brief knowledge about channels in our last episode. We mentioned the examples of RGB images, so let's take that again. We initially started CNN basics with a black and white image because it has only one channel, but an RGB image has three channels, as you can see: red, green and blue. So why three channels? Because all three channels together make the image, give colors to it. We have seen such examples in CSS, HTML and all. So as it has three channels, each pixel would have a definite value for red, green and blue, right? So similarly, when we proceed in CNN, we had discussed something like how an image undergoes a CNN. Similarly, we will have multiple channels. Given an RGB image starts with three channels, we will be having 128 to 56 channels when our CNN operations end. So we had mentioned in the last episode that as we progress, the number of channels would increase, resulting in more information about specific features in an image. So here you can see an example of an RGB image undergoing CNN operations, right? So do you notice something? Yes, we have three channels and three kernels. We haven't seen such thing earlier, right? What we saw was a single kernel which was 3 by 3 or 4 by 4 dealing with the input tensor. But here why 3 by 3? It is obvious actually, but let's explain. You can see three channels, right? So we were undergoing dot products. So as you can see in the previous examples, we said first we multiply each element with corresponding element in the cell and then add up everything to get a single value which we will store in the output tensor, right? So similarly, you can see that there are three channels. So considering the size of the kernel, which is 3 by 3 here, we know that this would be the first tensor we need, right? I have marked here, you can see that. Similarly, there are three tensors behind. So we need similar amount of kernels to deal with it, right? So here in total we have three 3 by 3 tensors. So we need three 3 by 3 kernels. So you can imagine this as a cube here. You can see, right? So this portion, this would be the first tensor, then the green 3 by 3, then the blue 3 by 3. Finally, each tensor will deal with the corresponding kernel tensor. You can see this first one will deal with the first tensor, the red one. Similarly, the green and the blue. Now let's see how the values will be distributed in the kernel and how the operation goes, right? I have mentioned a picture here. I think this is a clear representation of the mathematical operation happening in a multiple input channels. So let's see. Here instead of 3 we have a 2 channel input. So you can see the two 3 by 3 tensors. So our input is two channels which is each 3 by 3 tensors, right? Okay. So as I mentioned earlier, we have two kernels. So okay, let's make this clear first. So I had mentioned examples earlier like edge detection and all. So in those cases we had 1 1 1 0 0 0 minus 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 1 similar values for the kernel. So you can either have same values for the kernel or it can differ. It's up to you, or it can be randomized also. So whatever works is best. So you can see we have two input tensors and two channels in the kernel also. So here the values are different. The first kernel tensor has 0 1 2 3, then the other one has 1 2. Behind I think it's 1 2 3 4. Yeah, you can see that. So let's see what's happening. So as mentioned in the basic case, which was a single channel tensor, here corresponding elements are multiplied. 0 into 0 plus 1 into 1 here, then 3 into 2, then 4 into 3. Then the tensors behind also undergo the similar corresponding mathematical operations. So you can see here. Well, let's check if it's right or wrong, right? So 1 into 1, 1, 1 plus 2 into 2, 4, so 5. 5 plus 4 into 3, so 5 plus 12, 17. So 17 plus 5 into 4, 20. So 34, then 0, then 1, 35, then 3 into 2, 6. Yeah, finally we get 56, right? So this is how the mathematical operation undergoes. So let me brief it again. If you have multiple input channels, we will have corresponding number of channels for a single kernel. We will have multiple output channels, which we will come to earlier. So now we are focusing on multiple input channels. So here the concept is number of input channels you will have corresponding number of channels in the kernel, so that the corresponding elements get multiplied and final addition gives us a single element. So here, even though you consider two input channel tensors and the two channels in the kernel, the final output is a single value, which is 56, which is stored in the first case. Similarly, when you can see here in the next stride we had mentioned the number of units we have to change the CNN. So if we move by 1, then we will consider this tensor, right, and this tensor behind. Then when we multiply, we will get the value of 72. So similarly the stride goes on, then 3, 4, 6, 7, so it goes on. So that's how we undergo a multiple input channel in CNN. So initially we can prove this with the example of RGB images, which is red, green, blue, usual images we see. So there the input channel is 3. But I had mentioned as we go on in CNN, the number of channels keep on increasing. Then this operation is really important and you should understand this. The reason why you should understand this is because then only you would understand the size of the weights, the kernels, the bias and all. Also it gives you a great knowledge about how image undergoes CNN and how multiple channels help an image to get more features out of it, right? So now that we have discussed multiple input channels in detail, I am sure this video has helped you a lot in getting a deeper understanding in convolutional neural networks. In the next episode, we will be discussing about multiple output channels. The reason why I am not taking everything together is you should first understand this really well. The reason for which we are using multiple kernels here and how each channel is multiplied with the corresponding tensor, and then how the final mathematical operation undergoes, and finally we get a single value which is stored in the output tensor. So we will discuss multiple output channels in detail in the next video. Till then, bye. Subscribe to Professional Cipher.